Assalamualaikum warahmatullahi wabarakatuh and a very good afternoon. Welcome back class. Okay, selamat Hari Raya Maaf Zahir Batin. Welcome back to our reality after about more than 1 week of Hari Raya celebration. Yeah. So we're back in business. So we are already start our chapter 3. Chapter 3, we will cover chapter 3 within about 3 weeks. We need 3 weeks. So for the first part of the chapter 3, we'll try to go slow so that you can grab the gist of the kinematics equations, slow and steady pace. So we don't need to rush the learning experience. So we develop our ability within very suitable pace for you guys, not that slow, not that fast, so that you can grab the gist of the kinematics. So most of you have learned kinematics during your secondary school, in SPM, and some of you might just heard about kinematics within these few days only, but never mind. So I have prepared the slides to be interactive. There are simulations and there are also animations for you guys to understand in terms of graphically, in terms of images and so on and so forth. So let's see the kinematics equation. What is kinematics before that? Kinematics is a field of study to understand about movement of objects. Any movement of the object. It could be a movement of people, a movement of ball, car, aeroplane, ballistic, so on and so forth. So this chapter is very important for you guys. For example, if you want to be engineers, of course, kinematics, you will have to deal a lot of kinematics. For example, free fall, any object falling from certain heights, or any projectile motion, something you throw away. I mean, you're throwing something from one point to another point. So the movement is like a projectile. For example, if an athlete tried to throw a javelin, lembing, throw to javelin. So the movement of the javelin going up and then going down again. So there is projectile motion. So for those who are interested to join the armed forces, for example, the army or the PDRM, especially for those who are interested in CSI, to be CSI Malaysia, investigating officer, IO. So kinematics is one of the important things for you guys. For those who are working at the Bukit Aman ataupun pakar ballistic, the ballistic specialist in Malaysia. I have a friend, my classmate during my secondary school. So he's now the specialist for bomb, Bukit Aman. So his name is Hafizul Helmi bin Hamzah. You could try to Google for that name. You find out that he's a special bomb specialist in Malaysia. So few cases we have heard before in Bukit Bintang and some in certain areas in KL about bombs. So he's the IO, he's the CSI in Malaysia who came down and tried to investigate the ballistic effect of the bomb. So if you're interested, not just as an engineer, maybe you would like to join the armed forces. So kinematics is the key for you guys. Right? It's very simple. We just need 3 important equations only. Simple. 3 important equations only. Yeah. Okay. Now let us see the kinematics. Hold on. So where is the slide? Okay. So the learning outcomes, only 2. We need to be able to define and distinguish position, displacement, speed, velocity, and acceleration. Position could be the x coordinate. So most of you have learned the x and y coordinate of Cartesian coordinate. Pasti x kita belajar, pasti y kita belajar. So position could be defined as x coordinate, also y coordinate. Remember, for diploma level, we only learn 2-dimensional coordinate system, combination of x and y coordinate, 2-dimensionals only. 3-dimension in real world calculations, that will be covered in degree later. What else? Position, displacement, displacement and distance. We have learned the differences between displacement and distance. One is vector, one is scalar quantity. Speed and velocity, one is vector, one is scalar quantity, and acceleration. So using position, displacement, speed, velocity, and acceleration, we will learn 3 important equations for kinematics. Very easy, right? Then second one of the learning outcome is to apply constant acceleration equations, which the 3 equations to solve the one-dimensional problem or two-dimensional problem. And this is our plan and delivery. Chapter 3, part 1, we will cover 3.1, position, displacement, speed, velocity, and acceleration, which we have learned in chapter 2. So we could speed up things. And 3.2, motion with constant acceleration. Well, what does it mean by motion with constant acceleration? Meaning that the acceleration is maintained. But when acceleration is maintained, our velocity keep on increasing steadily. What does it mean? I will tell you later. Okay, now let us see the next slide. The first one, position. Position is used as a reference frame and coordinates. If we want to study movement of things, we need to have a reference frames and coordinate. Remember, we are playing around with X and Y axis only. No Z axis. We are solving 1 and 2-dimensional system only. For diploma, it's like a plane. Only plane, not 3-dimensional system. Macam dalam pergerakan satu satah yang mendatar. The XY plane, we call it. Not XYZ plane. XY plane only. So, first, the definition of position. Position is a vector quantity. Remember, position is a vector quantity, not scalar quantity. We need to define the magnitude and also the magnitude, also the direction. The position, magnitude, and direction. So it's a vector quantity that describes where an object is located relative to an origin. So we need to define the origin of the object first. So after a certain movement, then we know the final position of the object. Then we could calculate the position of the object using vector subtraction or addition. Sign convention, we must choose positive direction. Let's say if it is moving to the right or upward, so we use positive direction. If it is moving to the left or downward, then the sign must be negative. Upward, to the right, this is my right, this is my right. Maybe this is your left, but this is my right. Upward and right, positive. Left and downward, negative. Or how about circular motion? Circular motion counterclockwise is positive. Clockwise direction is negative. Now remember this, counterclockwise is positive, clockwise direction is negative. Remember that. Up, down, left, and right, counterclockwise, clockwise. The sign convention must be defined carefully. Certain textbook, they use inversely. Both are correct. We have 2 school of thoughts. Certain textbook, for Oxford textbook, we use upward and right and counterclockwise as negative. And the other textbook from America, I think, upward, right, and counterclockwise as positive. Both are correct, but we need to pick one. We need to pick one. So usually in Malaysia, we will use upward, right, and counterclockwise as positive. Ke atas, ke kanan, counterclockwise, positive. We use that in Malaysia. Now remember that sign convention. Now in one-dimensional coordinate system diagram, as shown in the slide, the position vector points from the origin to the object's location. So the origin, the initial location of the object is at the origin, the x equals to 0. So after certain movement, it moves to the right of the x-axis. It moves to plus 6 meters. It moves to the right. If it is moved to the right, then the final location is positive because it moves to the right. See, that is how we define the position. Plus 6 meters. So people know, oh, this object has moved to the right 6 meters. Why to the right? Because it's x coordinate. X coordinate means left or right only. So if it's plus 6 meters, x coordinate, it means it has moved to the right about 6 meters from the origin. As simple as that. So if I wrote x equals to negative 6 meters over here, it means that the object has moved to the left 6 meters from its origin. The origin not necessarily must be x equals to 0. Let's say if the origin is x equals to 2. So if x new is x equals to negative 6, it means that it has moved to the left about 8 meter. Macam tu. Macam mana sir? Saya confused. Tak apa. Never mind. I have examples for you after this. Now, let's see the distance and displacement plot. Sometimes these things quite confusing. Hold on. Somebody call me. Sometimes ni lah ada WhatsApp saya. Dia call saya lah. Okay, never mind. So where we? Okay. The difference between distance and displacement. So distance is a scalar quantity. We only need to take care of the magnitude only. Magnitude. Distance doesn't have any negative value. It always positive because we only concerned about the magnitude. Magnitude can be anything. No matter it is moving upward, downward, or rightward, leftward, or counterclockwise or clockwise, everything in distance must be positive because we don't care about the direction. If we don't care about the direction, we don't want to know whether it is moving to any direction. But the displacement is a vector quantity. We need to define the magnitude and also the direction. The direction must have positive and negative. For example, if it's moving along the x-axis, so positive means it moves to the right, negative moves to the left. So if it is moving up or down, so positive means it moves upward. Negative means it moves downward. If it is in circular motion, if it's moved counterclockwise, it means positive. Clockwise direction, it means negative. So those are the differences between distance and displacement. One is scalar quantity, one is vector quantity. Right? So the definition of distance is the total length of the path traveled by the object. Any movement, wiggle or straight line or up and down. So the total path it has moved, no matter which direction, we just total them up. Just use calculator and hit the calculator directly, you got the distance. But displacement, let's see the definition. It's a straight line change in position from start to end. It means that the shortest distance between the initial position to the final position. Let's say this is the initial position and this is the final position. If it move up and down, circle around and go to the final position, we don't hit the calculator all the total movement, but instead we take the shortest distance between the initial position to the final position, straight line. That is displacement. As I mentioned in the visualization at the bottom of your slide, I showed the differences between distance and displacement. You have the starting point over there, the start S1, and you have the end point over there, S2. So the displacement, if an object moves from S1 to S2 using any, let's say for this case, projectile motion. Okay, if I ask you to calculate the distance, you should calculate the total distance of the dashed lines. Dash line, the real distance following the path taken by the object. You take that as distance. But displacement, you take the shortest distance from your initial position to the final position. That means the straight line connecting the starting point and the end point. And you measure that straight line, that is your displacement. Right? So these are the differences between distance and displacement. What else? Let's see. So this is oops. Let's see some example. This is example one, soldier walking. Let's say we are looking from the top view. So below us, there is a soldier walking. We look from helicopter view, top view, and we look, there's a soldier who walks 70 meters to the east. So we draw the line, 70 meters to the east, denoted by the dark arrow, the dark arrow. So the starting point of the soldier is at 0 meter. So the x-axis for the soldier starting from x equals to 0 meter. So it moves to the east, 70 meter to the east. To the east means to the right. Ingat arah mata angin, we have east, west, north, and south. So our right is east. Usually like that, okay? East to the east. So it 70 meter to the east. Then what else? And then turning around and walks back to the west, 30 meter. So he moves 70 meter to the east and he moves back 30 meter to the west. That's the question. What is the total distance of his walk? That is question number one. And question number two, what is the total displacement? Very easy. As I mentioned before in previous slide, the total distance, you sum up all the real distance that he has walked. So he walked to the east 70 meter and he walked to the west 30 meter. Distance is scalar quantity, no negative. All are positive regardless the direction. So just add up 70 plus 30 without taking care of the direction. No matter east, west, or north, or south, just sum up everything. So you got 100 meter. That is distance. How about the total displacement? The total displacement is this is the shortest distance between the starting point to the end point. So your starting point is at 0 meter. So the end point, after he walked 30 meter to the west, it means that your x-axis now, the coordinate is 40 meter. Why? Because 70, he went back 30 meter, 70 minus 30, you got 40 meter. So now your displacement is 40 meter plus sign, positive 40 meter. Not negative. Negative only, he walks 30 meter, that is negative. See, I put over here. He walks 70 meter to the right, that is positive 70 meter. This is the calculation of displacement. Now, he turned back to the west 30 meter. It means that he walked back 30 meter to the west, and this is negative 30 meter. So 70 minus 30, you got 40 meter, positive. It seems like you are walking to the east, but only 40 meter. Even though he has turned around, but he stops before the line ends at 0. He stopped at x equals to 40 meter. So it likes the total displacement is like you're only walking from 0 meter to 40 meter. Okay, this is example number one. Quite straightforward. You just need to follow the movement of the soldier. First, he walks 70 meter to the east, positive 70 meter. Then he walks back 30 meter to the west, negative 30. 70 minus 30, you got 40 meter, positive. That is your total displacement. You just need to do sequentially. Follow the movement sequentially based on the example given. All right, now let's see example number two. If we have, yes, we have example number two. So it's a movement, hari raya lah. People move from one part to another part of the location, kan? So imagine that you're moving. Your car is moving from Bentong to Temelloh, Kuantan, yeah. So we have Bentong nearby Kuala Lumpur already. Then you are heading to Kuantan, and before that there is checkpoint at Temelloh. Temelloh is in between Kuantan and also Bentong. So the problem is the distance BK. B is Bentong, K is Kuantan. The distance from Bentong to Kuantan is 170.5 kilometer. If it is a straight line, imagine that it is a straight line. So our engineer did very good job. So the new highway from Bentong to Kuantan is a straight line. So you could use your Suku or RS or whatever motorcycle, the latest motorcycle, try to lock your throttle after you have done some upgraded specification of your motorcycle. Very straight line, so you know the top speed of your motorcycle without having any trouble about bends or whatsoever. So the distance about 170.5 kilometers. Siapa berani tanpa jam motosikal, silakanlah 170 kilometer lock throttle tanpa jam. What else? So while BT is Bentong to Temerloh, the distance is about 89.9 kilometers. Right. So if one travels from Temerloh to Bentong, TB, Temerloh to Bentong, he goes from Temerloh to Bentong, link number 1. At the diagram, look at link number 1, the one with dotted lines, and the orange dotted lines, Temerloh to Bentong, and then to Kuantan. So he, from the middle, Temerloh, he go down to Bentong, then after that, he goes back to Kuantan. So TB, BK. There is a link number 2, BK is link number 2. So the question, what are the total distance travel and total displacement? So you have two questions. One, you have to calculate the distance travel first. The distance travel, distance. You remember distance means it is a scalar quantity. No negative, all are positive. You just need to total up everything. So distance, no negative, all are positive. So Temerloh to Bentong is 89.9. Then Bentong to Kuantan is 170 plus 89.9. So in total, you have 260.4 kilometer. Everything is positive. Macam tu kan? Everything is positive. What else? Now you need to calculate the displacement. Now the displacement is the shortest distance between the initial position to the final position. You just need to take a look at the initial position. The initial position is Temerloh. Final position is Kuantan. So you just need to add up from T to K only. So TB or BT is 89.9. BK or KB is 170.5 kilometer. So how would you to calculate that? So if that is hard, so initially if you can imagine this, you just need to calculate about 170.5 kilometer minus 89.9. If you could imagine it in your head, but if you could not imagine in your head, do it sequentially. Just like example number 1, I asked you to do it sequentially based on the question. Now, the first movement, your initial position is at Temerloh. He moves to Bentong, and Bentong is on your left. Because Bentong is on your left, so your movement should be negative 89.9. So your first leg is negative 89.9. So from Bentong, you move to Kuantan, and your movement is positive because it moves to the right. So negative 89.9 plus 170.5, there you go. Your answer is 80.6 kilometer. Very easy? Yes, you just need to know if it is moving to the left or to the right. And you have to follow the sequence. Because the movement is from Temerloh to Bentong to Kuantan. I do not change the sequence. Sequence is very important for kinematics. Right? Got it? Very easy. Follow the sequence. To the right, positive, upward positive, left negative, downward negative. Remember that. Okay, now let us take a look. Next slide, this is slide number 1. Speed and velocity. Yes. Speed and velocity. Let's see speed and velocity. Speed and velocity, both are, speed is a scalar quantity. It only has magnitude. How fast? Laju. In Malay, is laju. No direction. We don't care about the direction of the speed. Just like your speedometer, it only gives you the magnitude of your speed. No direction involved. How about velocity? Velocity in Malay is halaju. Hala plus laju. So it has both magnitude and direction. There is no meter in real life that could give you the velocity. No, tak ada. Kita ada speedometer saja, tak ada velometer, tak ada. Speedometer saja kita ada, right? So the speed, the formula is average speeds, the total distance traveled divided by time. That's it. How to calculate speed? The total distance, not displacement. The total distance traveled divided by time. Time, using your watch, you got time. How about velocity? The average velocity is different. It's not the the total distance, but the total displacement. You already know how to calculate distance and displacement. So if you want to calculate the speed, you use the distance. If you want to calculate the velocity, you use the displacement. Remember this, or else your calculation will be wrong. Huh? Speed is scalar. Distance is scalar, and distance can be used to calculate speed, also scalar quantity. Displacement is vector quantity. It can be used to calculate velocity because both are vector quantity. So distance divided by time, you got speed. Displacement divided by time, you got velocity. That's it. Easy. It follows through. You able to calculate the distance, you should be able to calculate the speed. You able to calculate the displacement, you should be able to calculate velocity because the equation is very easy. Distance divided by time or displacement divided by time. You got speed. Another one, you got velocity. It's very, very super easy. Even though for newcomers, I think this can be understand easily. The gist could be grabbed easily. So let's see the images down there. Visualizing the magnitude and direction of the speed and velocity. Look at the car with green arrow. So if you look, let's say the person inside the car drives, he look at the speedometer, 20 meters per second. That is your speed. And if you want to translate into velocity, if the car moves to the right, therefore your velocity is 20 meters per second from the speedometer and the direction is to the right, then it is positive. Unlike the car on your right hand side, the speedometer tells us about 20 meters per second and it moves to the left. So speed still 20 meters per second regardless of any direction of the car, but velocity is negative because the car is moving to the left. So how about if the car is moving downward? Downward is negative, then your car velocity should be negative 20 meters per second. So how about if the car launch upward, straight upward? Then your car moves positive upward, positive 20 meters per second. As simple as that. Okay, now let's see the interactive example. I think this is no. Hold on. So this is slide number, let's see, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We have another 2 slides to go. Super easy. Hari Raya mood. Super easy. 2 more slides. Okay, bear with me. So interactive example number 3. Runner. Siapa suka jogging ke apa pagi kan, saya tak suka, ataupun suka berlari kan. Alright, never mind. Let's see. Let us try to translate the movement of a runner in a position time graph. The position is y-axis, the time is x-axis. Now, this is simulation. The graph is simulation. You could play around with the graph. Now, given, look at number 1. Your graph is simulation. You could drag the blue and red points on the graph to explore. See over there? Over here? You can drag. You could drag this, you could drag that. So what? Okay, so I could drag the blue and red point, but what do they mean? Okay, fine. So over an interval of 1.9 seconds, the position changes from s equals to 19.9. Now, let me try to reset this. Reset first. Always reset. Okay, based on this reset setting, then you read the question. So over an interval of 3 seconds, okay, 1 over here, 2 and 3. Okay, the position changes from s equals to 50. See, the position is our y-axis. Maybe we are looking this from the top view, from the helicopter view. We could see the runner moves from y equals to 50, go to y equals to 30. Okay. Saat pertama dia berlari sampai ke sini, dia pergi y equals to about 43. Pada saat kedua Y dia dah jadi about 37. Pada saat ketiga, Y dia dah jadi 30. Ini yang dimasukkan dengan yang ni. Over interval of 3 second ni, 3 second. Saat pertama, saat kedua. I hope you could see my cursor. Saat ketiga. Harap nampaklah cursor saya ni. Temu kat sini, saya boleh kat sini. Yes, I could. Okay, semula. Over interval of 3 second. Ni, saat pertama, saat kedua, saat ketiga. Okay. The position changes from S1 equals to 50. So, sorry. Ni pada permulaan. The position of runner is 50 meter. Okay. Now, after 1 second, the position of runner already becomes about 43 meter kat sini, Pak ni. Ni, 43 meter. Saat kedua, the position of runner already become 37, Pak ni. 37. Saat ketiga, the position of the runner becomes 30. Imagine that we are looking of runner from the helicopter view. Alright. So, how do we calculate this? How do we calculate the average velocity? So, the average velocity can be calculated based on the slope of the graph. This slope of the graph tells us about the velocity. Velocity is the vector quantity. The slope of the graph. Slope ni can tell us about the velocity of the runner. How, sir? Okay, it's like this. So the y equals to 50 and the y equals to 30 that we have discussed just now, they are the position. And position is actually vector quantity. So the position can be manipulated to calculate the displacement, which also a vector quantity. Okay, the position can be used to calculate the displacement. If the displacement divided by time, we could get the velocity, which is also a vector quantity. All right. So we have this equation, which we have discussed before. Velocity equals to displacement divided by time. And how about the time? Time starts from 0 just now until 3 seconds, which we discussed in the question, kan? So our delta t is, this is final time, this is initial time. So the difference of the time is 3 seconds. 3 seconds. So T2 minus T1. T2 is over here. T2, final time. T1 is the initial time over here, 0. So the difference of time is 3 minus 0. You get 3 seconds. So delta t over here is this difference of time. This is 3 seconds. How about the displacement? Displacement is a difference of location. Displacement is difference of location. Macam mana? Ini dia. Difference of location is final location minus initial location. So this is final location because the runner moves from here to there. So this is your final location, or usually we will write as S2. How about this one? This is the initial location, the starting point. We always write as 1 ataupun Y1. Yang ni Y2. It doesn't matter what symbol you want to use. If it is Y-axis, you could use Y. If it is X-axis, you could use X. Or you could use S, simply as displacement. Sorry, this S2. This is S1. Right? So, the difference of location, always final minus initial. Final is this 30 meter. This is final. Minus initial. This is your initial. So 30 minus 15. Final minus initial. So you got negative 30.5. Oh, tadi bukan 30 meter. Saya salah sebut. Bukan 30 meter. It's 30.5. Kat sini saya salah baca rupanya. 30.5. Sorry lah. Spek dah kelabu sangat. So 30.5 minus 50, you got negative 19.5. Divided by time. Time always positive because time is a scalar quantity. Jam kamu tak pernah tunjuk arah. Ya, yang arah kalau ada kat jam tu itu kompas, direction, time, dia scalar quantity, tak pernah ada direction. So negative 19.5 divided by 3, you got your velocity is negative 6.5 meter per second. Negative sign indicates it moves leftward motion. Not leftward, sorry. It moves a bit downward. Salah, itulah tulis ni. Bukan leftward, downward kan. Sebab you are referring to y-axis kan, y-axis. Y-axis either upward or downward. See the movement of the person from here, it moves downward over here. Sini kan, dia ke bawah ni kan. Dia punya position of y. Position of y dia kat sini. Ini asal, ini yang baru. So daripada 50 dia turun kepada 30.5. Saya salah tulis ni, nanti betulkan ni, not leftward but downward. Not leftward, sorry, salah tulis. Right, betulkan tu nanti. Nanti confuse pula. Sir, kenapa dia bergerak ke kanan sir? Kenapa sir tulis kiri dan tak? You are referring to this position. Position kita adalah Y. Y adalah atas ataupun bawah. So from here, it moves. Looks like he moves downward a little bit kat sini kan. Tu. Sebab itu dia tulis negative 6.5 meter per second. Right. Now, final slide about the cyclist. Tak apa, kuliah kita pada minggu hari raya memang pendek saja. Do not worry at all, right? So problem, how far can a cyclist travel in 2.5 hours along a straight road if her velocity is about 18 km per hour? Okay, so starting point over here, t equals to 0 hour. This is our starting point. This one, alamak, asal tak boleh. Oh, ini. Starting point. Let's say, dia tak beritahu kan? Sir, but dia tak tulis lah sir, berapa bergerak kiri atau kanan. Okay, this is my tip for you. Let's say, look at the question. The question did mention that the velocity is 18 km per hour without showing the direction kan? But the value of velocity is positive. And therefore, you could draw the diagram or the picture. Because it is positive, it moves to the right. Because it's positive. That's why the arrow is moving to the right. Because the value of the velocity, this is not a speed, this is velocity, this is a vector quantity. So because it is positive, it moves to the right. Okay. So your starting point is at t equals to 0 hour. At starting point, before you hit the stopwatch, your time is 0. Your starting point. This is not the beginning of the time. Bukan the beginning of the time. No. Ini pada waktu you nak set you punya jam tu. This is t equals to 0 hour, 0 second or 0 hour, right? So the question again. So you know the velocity moves to the right. How far can a cyclist travel in 2.5 hours? Without knowing the distance, we want to know the distance or the because this is a straight line. See, straight road. If the road is straight, so our distance and D is distance, S is, what do you call that thing? Displacement will be the same. If your road is straight, your distance will be equals to your displacement. Dia akan sama. Right? Kalau straight road. So it moves to the right 2.5 hours. Alright, we want to find the displacement or the distance. Okay, how do we do that? So we know that at our initial time, the time is 0. And after 2.5 hours, our time is 2.5 hours. This is T2. And basically, this is T1. Remember, if you want to find the difference of time, T2 minus T1, 2.5 hours minus 0 hours. Still, your T is 2.5 hours. So the velocity now, we have this information. The velocity is 18.5 km per hour, positive. And your time is 2.5 hours. This is very easy. So by manipulating the velocity and also time, you could get this distance or displacement. Actually, you got displacement, right? Okay, atau secara method, if you don't remember this equation, you look at the unit over here. You have 18 kilometer per hour and you have 2.5 hour. So if you do some mathematical operation, you could get kilometer. Kan? 18 kilometer per hour. If you multiply it by the time, you will get the unit is kilometer. That is displacement or distance. So that is very easy. You don't need to memorize this equation. By logical thinking, by looking at the unit over here, yeah, kilometer per hour. Darab dengan hour, you will get kilometer. The this hour and this hour will cancel out each other. So there you go. Without knowing this equation, by logical thinking of mathematics formula, you already know 18 kilometer per hour times 2.5 hour, you get 45 kilometer. And this is your distance, or could be used to tell us about the displacement as well, because this is all of your movement is to the right and it is a straight line. So it could be distance, it could be displacement. So your final answer, the distance traveled or the displacement, is 45 kilometers. There you go. It's very easy. Right? So there you go, my students. These are the details about the kinematics equations for the Hari Raya mood. And let us meet physically next week on the Tuesday and Thursday. We will discuss this face to face in the class. So harap-harapnya semua akan balik ke campus in one piece. Okay, selamat Hari Raya. Maaf saya batin. Kita jumpa next week. Alright, class dismissed. Thank you.